Is there any YouTube channel who can tell me about AI in easy and simple words?
If you're looking for the best content online about artificial intelligence, then check Professional Shiksha channel.
All right, let's talk about artificial intelligence. You see it everywhere, right? From the movie your TV just knows you'll like to the crazy fast route your phone maps out. Honestly, it can feel like some kind of invisible, futuristic magic. But today, we're not just going to watch the magic trick. We're going to pull back the curtain, get backstage, and actually check the liars. Because AI isn't magic, it's mechanics, and we're about to see exactly how the whole thing is put together.
I mean, that word, AI, it's stamped on everything now, promising to change our lives, our jobs, you name it. Which brings us to the single biggest question of this entire explainer. When you strip away all the hype, all the buzzwords, how does a machine really go from just processing code to making a prediction or creating an image or, winning a game?
To get to the bottom of that, we first need to get our vocabulary straight. So let's start by building a really clear mental map of the three biggest terms you hear all the time: artificial intelligence, machine learning, and deep learning. And here's a hint. They are not the same thing. They're actually more like Russian nesting dolls, where each one fits perfectly inside the next. So, at the very, very top, the biggest doll, we have artificial intelligence, or AI. This is the big, broad concept. It's the ultimate goal, right? The grand ambition of building machines that could do things we normally associate with a human mind, like reasoning, learning, and solving problems. Think about a really good customer service chatbot, one that doesn't just look for keywords, but actually seems to get what you're asking and helps you find a solution. That right there is the AI goal in action. Okay, so if AI is the destination, then machine learning, or ML, is the engine that's getting us there. And this is where things get really clever. Instead of a human programmer trying to sit down and write a rule for every single possible scenario, which is, impossible, we completely flip the script. We just feed the machine thousands or even millions of examples and basically say, here, you figure out the rules. It literally learns the patterns from the data all by itself. Now, tucked inside the world of machine learning is this specialized, incredibly powerful tool called deep learning. This is the powerhouse behind all the most stunning stuff we see today, from voice assistants that understand you to AI that generates unbelievable art. It works using something called neural networks, which are these really complex structures of interconnected nodes, loosely, and I mean loosely, inspired by the web of neurons in our own brains. Each little node is like a tiny specialist, and by working together in layers, they can spot incredibly subtle patterns in messy, real-world stuff like human speech or the pixels in a photo. And this delivery drone example just pulls it all together perfectly. The grand goal, the AI, is super simple. Get a package from A to B all by itself. The method is machine learning, an algorithm that studied tons of traffic data to predict the absolute fastest route at 3 o'clock on a Tuesday. And the specialized tool? That's deep learning, powering a vision system that can tell the difference between a stop sign, a tree branch, and a kid's balloon in a split second. Goal, method, and tool, each one playing its part. So now that we have the concepts down, what do you actually need to make one of these things? Well, the best way I've found to think about it is like baking a cake. No matter how complicated the final result looks, the recipe always comes down to 4 fundamental building blocks. And if you look at the recipe here, it's actually pretty straightforward. First up, you need your data. These are your ingredients. You can't predict sales without historical sales figures, right? Second is the algorithm. This is your cooking method, the mathematical process that's going to find the patterns in those ingredients. Third, you need computing power. This is your oven. We're talking raw hardware horsepower, usually from specialized chips called GPUs that can perform trillions of calculations. And then, when it's all done baking, you get your final model. That's the finished cake, a trained system that's ready to make predictions on brand new data it's never seen before. Okay, so we've got our ingredients, we've got our oven. Now it's time to choose a cookbook. And in the world of machine learning, there are really 3 main strategies, or cookbooks, that tell a model how to learn from its data. By far the most common approach is something called supervised learning, and the name says it all. You're supervising the AI by giving it an answer key. You feed it a massive data set where every single piece of information is already labeled correctly. The classic example is an email spam filter. You show it millions of emails that people have already marked as spam or not spam. It just chews through all those examples, learning the tiny differences, until it can make that call on its own with amazing accuracy.
Then we have the total opposite, unsupervised learning. This time there is no answer key, it's pure discovery. You just give the AI a huge, messy, unlabeled data set and ask it a very simple question. What's in here? A streaming service might use this to analyze what millions of us are watching. And without any hints, the AI might discover these hidden groups of viewers, like, say, fans of old sci-fi who also watch cooking shows, revealing a whole new customer segment the company never even knew existed.
And finally, we get to the most dynamic method of all, reinforcement learning. This is all about learning by trial and error, basically like training a puppy. You put an AI agent into a digital environment and give it a goal. It gets a little digital treat, a reward, for actions that move it closer to that goal, and a penalty for actions that don't. An AI learning to play a video game starts out just mashing buttons randomly. But after millions of rounds of getting rewards for high scores and penalties for losing, it teaches itself strategies that are literally superhuman.
Now, these powerful ways of learning didn't just appear out of nowhere. To really get a handle on where we are today, it really helps to see where we've been. AI has been on a long journey, evolving from these early systems built on rigid, human-coded logic to the flexible, data-driven intuition that's defining everything today.
And as you can see on this timeline, the journey started way back in the 1950s, with researchers trying to literally write down the rules of human thought as lines of code. By the 80s, we had what were called expert systems that could copy the decision-making of one person in one specific field. Then, in 1997, a huge milestone. IBM's Deep Blue beat the world chess champion, proving a machine could outthink the best human mind in a game of pure logic. But the real game changer, the true inflection point, hit around 2012. That's when the explosion of big data and powerful, affordable computer chips finally unlocked the true potential of deep learning, kicking off the absolute revolution we're living through right now.
So with all this incredible progress, where do we actually stand today on the grand spectrum of intelligence? Well, this table lays it out perfectly. Every single AI system on the planet today is what we call narrow AI, or ANI. It can be superhuman at one specific thing, like an Amazon robot that sorts packages faster than anyone, but it can't do anything else. The other stuff you hear about, general AI, or AGI, with human-like versatility, and super AI, or ASI, that's way beyond us, that all remains firmly in the realm of theory and science fiction. For now.
Whew, we have covered a lot of ground, from the big ideas in the 4-part recipe to the 3 ways machines learn and the history of it all. We now have a pretty solid grip on the mechanics, but understanding how the machine works, well, that naturally leads to a much bigger and frankly more fascinating question about what it actually creates.
And that brings us to our final question, a sparring question for you to take away. If an AI model for hiring is trained on resumes from the last 20 years, a time when, let's face it, mostly men were hired for certain roles, will the AI it produces be efficient, or will it be biased? And if you were the manager, would you trust its recommendations? Thinking about questions like that, that's where knowing the mechanics of AI suddenly becomes about so much more. Thanks for joining me.
Thank you, Professional Shiksha. Your contents are very easy to understand.